Hi, everybody. Hi. I'm Claudiu. I work for Facebook in the infrastructure division. I'm a production engineer working in Dublin office. My area of activity or business, or how you want to call it, is data centers. Me and my colleagues do tooling for data centers. Us, in our space, do not see data centers as server farms, as you may imagine. We see them rather as industrial plants, or, I don't know, something that may seem scary for many of you. But it's not, because we use Python in our space. Before I dwell into the actual story of migrating one of our services from Python 2 to Python 3, I'd like to tell you about how Facebook came to use Python 3, or almost Python 3 only these days. It all started as an engineering effort a couple of years ago. There is a full article I'm linking here that you may want to read with the whole story. I'm just going to do a summary of that here. So it all started as an engineering effort, and it started slow because, well, there was a new kid in town, this Python 3, and everybody was used to doing things in Python 2. But things have caught up on speed, so the new kid in town soon, in relative terms, became the new normal. We actually crossed the 50% line this year. 50% line in sense of more than half of our code is now written in Python 3. I'm referring obviously on our Python code, not on everything else. Also, there is this issue here that people have started to consider using Python 2 uncool because, well, Python 3 offers so many nice features. But why did Facebook choose to switch to Python 3, and why didn't we stay put with Python 2? Because, well, as you may already know, Python 2 is actually going out from maintenance like close to 1 year now. But 5 or 6 or maybe 10 years ago, this wasn't the case. There were still 10 years in front of us at that time to take decisions on. Well, there are benefits in using Python 3. Well, services built with Python 3 use less memory. Well, that's a good thing. But for us, it was more like a bonus rather than, the main thing we were after. The truth is, we are after async code, async I/O. This is the thing that does improve user experience, and it matters most for everybody. So this was the main reason Facebook switched to Python 3 when it did. Async. And obviously, there is not much of a choice now that Python 2 is going out. So what are we doing with Python in our own space? This story is about our data polling service. Well, it may sound intimidating to think that we are grabbing data from big boxes like the one on the left and doing some magic in order to transform the data from there into the nice graphs like the one you see on the right. But it's nothing intimidating. It's Python. We use some industry standard protocols that are well known, and we just grab data and put it into some data storage for future processing. So everything looks fine from this point of view. But why did we need to switch to Python 3 on such a service that, well, up to that point was rock solid? It worked, it did its job. And, well, yes, we thought that, well, if it's something that is working, why change it? Well, we had this question asked, but we didn't have much of an option because, even in our space, new industrial protocols we care about come with Python 3 libraries only. Like subscribing to changes, having controllers notify us their state has changed is now possible with async I/O only. So we had to go on this path. And we went on this path. And as you may all be aware, it's quite easy to transform code from Python 2 to Python 3. There are even automated tools that do that. Most of the time you have to care only about the print syntax, exception syntax, how you enumerate dictionaries, how you generate list of numbers. Those 4 things, I believe, account for more than 95% of syntax changes you may occur on basically any code base out there. But unfortunately for us, it wasn't enough to care only about this. Because we are also doing some basic data processing over the data we are collecting from controllers. We are doing rounding. And this is trickier because Python 3 changes the way the rounding is done. Just think about rounding 2.5. If you do it in Python 3, you get 2. If you do it in Python 2, you get 3. That's quite a wild difference, and we needed to account for that. So in order to address our concerns, we had actually wrote an application, a tool that would compare the results from the existing production service with the release candidate. Obviously, in our space, we couldn't just compare states in time, because it wasn't enough. We had to work with streams of data rather than states, individual states. So things got a bit complicated, but I suppose explanation about this tool exceeds the scope of this particular presentation. If you want to know more on how did we compare streams of data, please do come talk to me at the booth, and I'll be more than happy to tell you how we achieved this. But then again, this particular tool was considered good to have it in our CI/CD infrastructure to validate all the new builds. And at that point, after this thing was put in place, we were thinking that we were like, I don't know, 2 hours away from going live with the release candidate, only that it wasn't that simple. And later, when I have discovered this particular song by Taylor Swift, I realized that she was basically telling the story of our lives. Basically, how to tell you, what we have seen so far was the fun and games. Afterward, it was the memory leak we had to deal about. And really, do you expect a memory leak in Python? We didn't. So as you can see, the memory usage kept on growing with our release candidate, while the production service kind of stayed put. Well, Python, memory leak, how was that even possible? You may wonder. Because Python is garbage collected. You shouldn't just waste memory like you do it in C or C++. But before even thinking about that, we were facing a bigger problem, because the original service, as it wasn't fully designed by us, the current team. It was originally written by a different team. There were people with different levels of experience adding things to the service, and we even had an intern project adding things to that service. So there was nobody in our team that could say, look, I know this service A to Z, and I know everything that's in there. So we had to spend time just to figure out, well, what's in there. And we have basically followed this list I'm listing on the slide. We went from changing things randomly to changing things on a much more ordered manner, and then we switched to a more systematic approach and found the problem. But let's start with random things. We have thought that we may be facing a bug in Python, so we have looked at the GC stats. Well, looking at those stats only proved that the garbage collector works. But we weren't after that. Also, we have taken a look on the number of objects of certain types, on list dimensions, and other data you can get from the Python binary using special tooling. But then again, there was nothing to be had from there. Also, volgrind. You may be used to using volgrind to debug memory leaks or other problems in your code. It wasn't of much use at the very beginning because we were missing debugging information. And also, volgrind makes your code run into some virtual machine, and that's really slow. And we didn't have that time to leave the service running for days just to reproduce something that was reproducible normally in 1 hour or so. We did find some issues in the code that were causing issues or had the potential of causing issues. Like we weren't closing connections properly. And yeah, we replaced that code, the open type of code, with the with construct. That was good on its own, but it wasn't enough. We have also found out at some point about a bug in Python 3.6. If I'm telling you, I'll be going to explain you a bit about what this is about. So it's a bug in Python core. If you're generating, if you're causing an error message to be generated, that particular internal memory structure would be duplicated by the Python, and the memory would be kind of leaked. But we were not being affected by that. So, yeah, after all this, we had our moment when we thought, look, why don't we just throw everything away and start from scratch? Only that, no, it's not like that, because for a single bug or for just a few bugs, you don't just throw away 1,000 or 10,000 lines of good code. But there was another thing that was possible to be done, and we've done it. I'm calling it the X or the scalpel technique, and I think it's quite a good technique to be applied on anything, actually. We have started to remove portions of our code. First, we have removed big plugins, and then, as we started to see some results, we went down to individual functions. The whole process was not as long as you think it was. It involved only some patience on our part, like we did our change, rebuild the service, put it live again, waited for half an hour or an hour until we see some results, if we were facing that problem or not. But then again, this helped, and this is the way we actually found our problem, because the problem was finally isolated to a single function that came from an import. We thought that was actually an import from a Python standard library, and this is why we kind of ignored that, because we didn't imagine that could cause a problem. But no, it was an external open source library that we were using to read controller data using SNMP. I'm pretty sure that not everybody in this room knows what SNMP stands for and what it is good for. The S from SNMP comes from simple. Well, it's the Simple Networking Management Protocol. Well, simple. It's an industry standard protocol that is used mostly for monitoring networking equipment, like switches or routers. In our space, we needed it to monitor UPSs. UPSs stand with servers in racks and help when we have power losses. This protocol supports both active reads, like the client coming over telling the controller, please give me the value of this particular point, and also passive reads, that is the controller telling the client, look, my state has changed, here is the new value. There are 3 versions of this protocol. We were concerned only about the version 1. That is the most basic variant of this protocol. And one thing to be also mentioned here, this is this particular open source software suite called NetSNMP, which is a low-level software suite, and it's actually the software suite. There is nothing else, actually. And all libraries out there act as interfaces between this big thing, NetSNMP, and client program. And our library that we were using was not an exception to this rule. And it was actually a library C written in C with PyCapsule Python integration. And basically, we had no visibility on this particular C layer. For us, it was black magic. And yeah, this is where the actual memory leak was happening. In that black magic layer we knew nothing about. Of course, being open source, we thought it should be really simple to fix a bug in an open source library. After all, there are some very well-known methods of fixing things in open source libraries. First, you could get the latest version and hope that your particular problem was fixed in the meantime. Or you could contact the maintainer and have them fix the problem for you. You could also go hardcore and put up a pull request, fix the library yourself, put a pull request, and make everybody happy. But unfortunately, we weren't that lucky, because we are already at the latest version and there were no maintainer in sight for this particular library. And yeah, the only solution we had involving this particular library was to fix it. And fixing it, you know, when you see such things that memory leaks were reported on this library even years ago, it makes you a bit concerned on the easiness of such task. But then again, we have went also on this path. The other option that we had was to replace this open source library with something else. And yeah, well, even if I'm putting the option 3 here, at this point, we did not have any other option but the first two, because we came to rely on SNMP too much. Fixing the library did not work, and I'm sorry to tell that. It was C code written with GoTo. This means that we could not just predict the actual code execution path. And one of my colleagues spent like a day just debugging things around there with Volgrind. There were segfaults to be fixed, and all kinds of craziness. And at some point, we had to call it quits. It wasn't worth it. There was nothing to be done on this path. We easily found an open source replacement for this. It was PySNMP, and if you need to use SNMP in your space, PySNMP is the way to go, at least for the beginning, because the integration is easy enough and the latency is acceptable. Well, it wasn't acceptable for us anymore because we got used to the low latency offered by a C layer. But trust me, it's not that bad. Also, we have looked at other C-based libraries, but they were kind of complicated. They were offering very complicated APIs while we were going for the basic thing that was hidden behind many layers of API. And yeah, it was not worth it. So what did we do in the end? Well, we had to look inside Facebook, because inside Facebook, our networking equipment is monitored with SNMP. Like everybody else's networking equipment in the world is being monitored with SNMP. And that particular team had their own code that was used to monitor those types of equipment. The only problem was that code was written in C++, and we had to put the Python binding for it. Of course, you're thinking, why did we get to this particular point here where we had to look inside and we did not, you know, start on this part from the very beginning? And why did we go open source when we could have gone here from the very beginning? It's about priorities, because in our space, SNMP was outside of the critical path at that time. So, being outside of the critical path, the decision was to go on the path of the least resistance. And the path of the least resistance was to go get an open source library and just integrate it, see it work, and yeah, that was it. In the end, yes, we had this C++ library that we have integrated in our code using Cython. Cython is a very interesting tool. It actually compiles Python code to see behind the scenes. And this is why it's very easy to integrate C++ code into Python. It also has this particular thing. It can run code outside of the GIL, the global interpreter lock in Python. And this made a difference for us. And this is actually the final result as we got. On the left, you can see the memory usage with the open source library we have initially using. On the middle, the PySNMP integration, and on the right, the final state with the library that we ended up using. But, you know, even after we went live with this, a question remained. Why was it even possible for this to happen? Because it worked with Python 2. There was no memory leak with Python 2, but the memory leak appeared with Python 3. The long story short, we do not know. We have our usual suspects, but we still do not know. If any of you knows more about any optimization in Python 3 that could have caused such things to happen, please do come talk to us. In the end, I'd like to tell you about the lessons we learned when we solved this problem. The first and the biggest lesson we have learned was that if there is a difficult problem on the table, you need to bring more people to look at it. You cannot just go alone. More people means more experiences, more visions, more ideas. Also, sometimes it's not easy to solve a problem just by looking at it. You need to go deeper. But you also must take care not to waste too much time on a false lead, or if something doesn't prove successful, you need when to stop. And this is also about experience and maybe also luck. The third thing is that open source is not the solution for everybody, unfortunately. It wasn't for us. Well, we thought it was, but in the end it wasn't in this particular problem. While open source is a massive force of progress, it is. Not everything out there is, how to say that, well maintained. Thank you.